add or subtract the following rational expressions. Reduce the final answer. In exercise A, we have 5x plus 3 over x minus 4 plus 23 over 4 minus x. And so we've seen this situation before where we have this 4 minus x as compared to x minus 4. We've seen that it's the opposite. And so if we think about this a little bit, right, 4 minus x is the same thing as negative x plus 4. And factoring out a negative 1, that's negative 1 times x minus 4. So, I can rewrite this as 5x plus 3 over x minus 4 plus 23 over negative 1 times x minus 4. So now, well, let's take that negative 1 that's in the denominator of that second fraction and move it to the numerator. So we have 5x plus 3 over x minus 4 plus negative 23 over x minus 4. And so now we see that we have a common denominator of x minus 4, and we can add these fractions. Alright, so that would give us then 5x plus 3 plus negative 23 over x minus 4, which simplifies to 5x minus 20 over x minus 4. So we've got these to a single fraction. Now we always want to check and see if we can do any factoring. Notice that 5x minus 20 is equivalent to 5 times x minus 4. And the denominator is still x minus 4. And so we can remove this common binomial factor of x minus 4 and replacing them with 1's. And so we're left with 5 times 1, which is 5, over 1, which is 5. Alright, exercise B. We have n over n plus 3 subtract n minus 7 over n squared minus 2n minus 15. Alright, so we need to find a common denominator before we can subtract these fractions. So the first thing that I'm going to do is factor that second denominator. So let's do a little side work here. N squared minus 2n minus 15 factors as n plus 3 by n minus 5. So notice in the first fraction we already had a factor of n minus 3. And so in the second fraction we have n plus 3. In the second fraction we have a factor of n plus 3 and a factor of n minus 5. So then our LCD is n plus 3 by n minus 5. So we don't need to build up the second fraction, but we do need to build in a factor of n minus 5 in the first fraction. Alright, so then this gives us, let's see, the first fraction, n times n minus 5 is n squared minus 5n over the denominator, which is n plus 3 by n minus 5. Subtract. Now remember, when we subtract, we always want to put parentheses around that second numerator. Alright, so now I have these two fractions. They have a common denominator, so I can combine them to a single fraction. So I'd have n squared minus 5n minus the quantity n minus 7 over the denominator, that's n plus 3 by n minus 5. Remembering that subtraction distributes through all of the terms. This would give us n squared minus 5n minus n plus 7 over the denominator. Combining the like terms in the numerator gives us n squared minus 6n plus 7 over n plus 3 by n minus 5. Alright, and we want to check to see if we can factor the numerator. Does anything multiply to 7 and add to negative 6? No, nothing does, so we're done. We've simplified the expression. All right, in example C, we have negative 10 over a squared minus 25 plus a plus 7 over a squared plus 8a plus 15. All right, so first let me get a common denominator. And to do that, let's do some factoring. A squared minus 25 factors as a plus 5 by a minus 5 using difference of squares. And a squared plus 8a plus 15 factors as a plus 3 by a plus 5. So I see three distinct factors. So then my LCD is a plus 5 by a minus 5 by a plus 3. All right, so what do we need to build in? Let's see, my first denominator is a plus 5 by a minus 5. It needs a factor of a plus 3 in both the denominator and numerator. My second fraction is missing the factor of a minus 5. All right, so equivalently, I have negative 10 times a plus 3 is negative 10a minus 30 over the common denominator, which I'll write in its factored form as a plus 5, a minus 5, a plus 3. The second fraction, using FOIL, gives me a numerator of a squared plus 2a minus 35, again over the common denominator, a plus 5, a minus 5, a plus 3. Addition of fractions with a common denominator. Let me add the numerators. So that would give me negative 10a minus 30 plus a squared plus 2a minus 35. Now over the common denominator. And I can combine the like terms in the numerator, yielding a squared minus 8a minus 65 over the common denominator, a plus 5, a minus 5, a plus 3. All right, now let's see. Can I factor that numerator? Does anything multiply to 65? Well, it's divisible by 5. 65 is 5 times 13. So, and 5 and 13 have a difference of 8. So yes, I can factor it as a plus 5 by a minus 13. And the denominator is still a plus 5 by a minus 5 by a plus 3. And so notice we have a common factor of a plus 5. I'll remove it from both numerator and denominator, and we are left with a minus 13 over a minus 5 by a plus 3.